Our next step in our interest problems here will be to calculate compound interest when your money is being compounded more than once a year. Yesterday we looked at interest situations where everything was an annual interest rate. It was compounding once a year. In most cases, your money is going to be compounded, whether it be a debt or an investment. It's going to be compounded at a certain number of times per year, whether it be monthly, daily, quarterly, whatever that may be. You're generally going to be paid or charged interest more than once a year. So to do that, we have this new formula for calculating compound interest. And if you look at the formula, A equals P times 1 plus R over N to the NT, it's very similar to what we did yesterday, except you notice the letter N being new in this equation. What that N represents is the number of times your money is going to be compounded in a year. Now your A, P, and T stay exactly the same, and your N represents simply the number of times it will compound per year. And you're going to see the concept of APR a lot in the real world, where you hear this idea of an annual percentage rate. And what that means is, if you're getting paid 5% interest, if that's what your account says, or if you're being charged on a loan 5% interest, and they compound it monthly, that doesn't mean they're going to pay you 5% per month. That means they're going to pay you 5% throughout the year. So that's why when you look at the formula, you see R divided by N. That represents the fact that you're taking your rate and you're dividing it by the number of times you're going to compound in a year. So therefore, if you're compounding monthly, you're only going to get paid 1/12 of your rate for that month. And then the reason we multiply N times T up in the exponent is because the NT up there refers to the number of years times the number of times it compounds per year. Because that number of times it compounds in a year times T will give you the number of total payments you will get on your interest. So let's look at an example of a situation where you have your money being compounded more than once a year. So in this situation, we're talking about an individual who invested $6,800. So we're going to plug into the equation similarly to what you did yesterday. 6,800 times 1 plus my rate, and we always make the rate into a decimal. The only difference is now the rate is going to become the numerator over our N value. N refers to the number of times we're going to compound per year. So therefore, if we're compounding monthly, there's 12 months in a year. That's going to be, my N is 12 to the power of 12 times 10, because we do N times T, where T is the number of years. Now, this can be plugged directly into your calculator, being careful with one thing. If I was going to plug this into my calculator, now some of your calculators are more capable than others, I would plug it in almost exactly the way it looks, but I would multiply 12 times 10 first, because you may run into an order of operations issue if you don't do that. So if you plug that into your calculator, you can, like I said, you can plug it in exactly the way it looks, and it will give you an answer of $10,341.75. Now obviously in these cases we're talking about money, so we would run around to 2 decimal places, and that would give us an even value for cents. So that means that this person, Thomas, who invested $6,800, now has $10,341.75 in his account after 10 years. So that's how your interest would be calculated. That's how they take an annual percentage rate and divide it over 12 months. There's some language you'll come across today as far as the compounding problems go, and they will be in reference to your N values, where N, we said, represents the number of times it compounds in a year. So you need to be familiar with each of these words. Annually means it compounds once a year, so N is 1. That's the formula we used yesterday, and if you think about plugging 1 into the formula, it keeps the formula we used yesterday exactly the same. Semi-annually refers to twice a year. Quarterly is 4 times a year. Monthly, 12 times a year. And daily, we'll use 365 days a year. It's technically 365 and a quarter, but we'll simplify and say it's not leap year and use 365 days in a year. The other topic we're going to cover today beyond compound interest is going to be exponential decay. Yesterday we talked about exponential growth, which connects into the financial side of compound interest. To finish up today, we're going to look at a couple of decay problems. And all decay means is to lose value or size. So it could be something that loses financial value, or it could be something that's decreasing in size. And so we're looking at a formula here. A equals P times 1 minus R to the T. And the reason why we have 1 minus R, a rate of, say, if we would talk about an example, we would say something loses 20% of its value. Well, we're not trying to calculate how much value it's losing. We're trying to calculate how much value it still has. So if it loses 20% of its value, it would be maintaining 80%. So that's why we do the 1 minus our rate. So in that case, 1 minus 0.2 will give us 0.8, which would be 80% of our value, which is what we're maintaining. So that's why we use the minus in the formula. And you'll also note here that we're always going to be talking about an annual interest rate, because we don't do decay monthly or something like that. It will always be annual, so there's no n in the problem. Alright, so let's look at one example of this. If you bought a car, we all know a car loses its value over time. Well, you could research, the type of car and the average value that is lost in your car per year. And that'll come out as a percentage. And so in this case, we're looking at a new car that loses 8% of its value in each year. So therefore, if someone purchased that car for $12,000, they want to know how much that car is going to be worth in 4 years. So we plug into our formula. We want to know A, where $12,000 is our initial investment, and we're going to lose 8% per year. And we said that'll go on for 4 years. So it's a simple formula, just like what we did yesterday. And you can plug that in again exactly the way it looks into your calculator, and your calculator will give you that that car is now worth $8,596.72. So anytime you're looking at decay, you will recognize there will be a minus in the formula. That subtraction means it's decay. Anytime your multiplier is less than 1, your value is going to go down, so that'll represent a decay problem. All right, good luck to you.